Try to understand. This is our second law of motion. It is saying the second law of motion is saying F is equal to ma is not exact. It didn't came directly from the second law of motion. No, this law defines that the rate of a change of momentum is directly proportional to external force. Okay, external force. So F is known as external force. Okay, this F is equal to ma, which is directly proportional to momentum. Ma is not a momentum. Mb is a momentum. Okay, Mb is a momentum. This we can write F vector is equal to dp upon dt with respect to time. With respect to time, P can be written as mb upon dt. Then here just we differentiate it, and then case number one is the same. Number one case is if mass is velocity, mass is constant, then this term will become zero. Okay, and this first will exist for external force. Case second is if a velocity is a constant, then this differentiation of a velocity constant will become zero. It means this term, whole term will become zero. And this second term will exist for external. If force is equal to this is zero, so vector B into dm upon dt. We will use this formula when velocity is constant. Okay, when velocity is constant. This will be used when mass is constant. Okay, when mass is constant. When mass is a constant. There are two cases of a first rocket propulsion. We will see. There are some questions based on this equation. We will see later. This is a quantitative definition of a force. This is a fundamental law. First and third law drive defined by second law. Means we can drive a first law by the help of a second law. We will see. Okay, and as also third law. Also third law. Now let me erase it. Let me erase it. Next we have average force. Okay, average means complete. Average force during the journey will be equal to total delta p, which is vector, delta t, which is time. Okay, this equation will give us an average force during the journey. What was average force? Okay, this formula will be used. So over here nothing is different from the previous, just delta v2. Delta is used for total. Okay, for total. So total momentum upon total time will provide average force. Okay, direction of a force will be same as that direction of the change of momentum. Whatever will be direction, whatever will be direction for P will be also for the force. Okay, for force. Okay, same direction. Long and short, same direction. Next we have F is equal to, look at over here. F is equal to can be written as dp upon dt. Yeah. Just for instantaneous force. Okay, this is known as instantaneous force. For instantaneous force we have dp upon dt. For total average force we have delta p upon delta t. Both are different, little bit, not too much. Remember, in this you can see there is a relation of a PT. So PT graph will give us, PT graph will provide force, will provide force, FORC, as you saw about VT 80. So XT is for velocity and VT is for acceleration. Same over here. PT, P is a momentum, T is a time. PT is a relation of force. Okay. When we differentiate this PT, differentiation of a PT will be differentiation. Okay, differentiation of a PT. First, this will be we will do over here differentiate. We will differentiate it. Next, slope for this will be tan theta. Okay, slope for this will be tan theta. For dp upon dt, slope over will be tan theta. If angle is given, then we will use the tan theta formula instead of dp upon dt. Okay. Slope of momentum time graph is equal to force on the particle at that instant. Now this was about the differentiation. Now let's see integration of a force. Integration. Okay. So this total momentum, to calculate the total momentum we will have F multiple dt. So dp this will go, dp is equal to F multiple dt. Here we want a total momentum, so dp will be equal to F into dt. Integration. Okay, we are doing integration. So limits, we will put our limits. You will put our limits from initial to final. How did it come? From here, dp can be equal to F into dt. Here dp total momentum we are finding. So P1 function is of momentum, P1, P2. Over here T1 is a function, T2. Okay, this formula we will use. There are some questions based on this formula. So here we are doing integrating it. So remember FT graph will provide nothing but area means change in momentum. Clear? Change in momentum. When we will differentiate, then we will get a change in momentum. Okay, this formula is what? Very easy. Integration with the limit dp is equal to integration of F into dt. Okay, F into dt. And instantaneous force is equal to dp upon dt. Over here, average of force is equal to delta p upon delta t. Average force is equal to delta p upon delta t. For instantaneous force is equal to dp upon dt. For total change in momentum will be equal to integration of F into dt. Clear? Limits will be compulsory for this. Limits will give us from where to till where. Okay, to till where. Now important points, let's see important points. Remember, this is second law of motion. It defines force. Okay, it will define force, and the second law of motion measures force. Means first FIRST, first law of motion will define force. Okay, force. it will tell you that yes, first law of motion says that yeah, something, if we want to change we want to change the state of object, then we will apply force. So this first law of motion is talking about external force, but when it comes to second law of motion, then we it says that how much amount of force it will tell you. Okay, from first law of motion, we have identified that yes, force is compulsory, external force is coming to change a state of object. But second law of motion, we will use this formula to calculate of amount of force, how much force was applied to change a state of state of object. Okay. Third equation, not the third equation, but third law of motion will tell you action reaction pair. Action reaction pair. We will say action reaction pair. Action reaction pair. Next. Action reaction pair. Next point is if a particle move uniformly means velocity is zero. Velocity is not zero, velocity is a constant. Okay, with the same magnitude, velocity object is moving with the same aspect. Let's just say aspect is 5 meters per second. So during the whole journey, well, aspect is the same, 5 meters per second. It is the meaning of uniformity. Means velocity is equal to constant. Clear? Reason is this word is reason. Uniformly, which means equal. So for this condition, we have acceleration is equal to dv upon dt. Where velocity is zero. So velocity is not zero, but velocity is a constant. We know acceleration will become zero. That this will happen. So acceleration will become zero. So remember, this is a fact. It's a fact that if velocity is constant, then acceleration will become zero automatically. Okay, automatically. So you can say acceleration is zero. It means over here a multiple a is zero. So external force is coming zero. Means this is what? This is following the first law of motion. This statement is following the first law of motion. The reason is net force is zero, external force is zero. Okay, this is our fact. Remember, if velocity is a constant, acceleration will become zero. External force F net will come as a zero. Next, it means that in the absence of external force, a particle moves uniformly. There is no external force, then particle will be moving without having any external force. Okay, if object is moving. With the help of it means in the mathematically Newton's first law of motion with the help of Newton's second law of motion, we can prove. Now next, remember, if object is accelerating, it means there is an external force. If accelerated motion Accelerated motion is a directly is always due to an external force. External force. We will get a object which is oscillating due to external force. Okay, whenever you are observing that object is accelerating, then you can observe that yes, external forces or something. External forces are not equal to zero. Okay, you are finding this thing. Reason is object is accelerating. Object is accelerating. Law of conservation of linear momentum is applicable in the direction in which external forces is zero. Over here, try to understand if x is zero, then our dt x upon dt will be zero. Then px is equal to constant. Here if y is equal to zero, then dpy upon dt will be equal to zero. It means py is equal to constant. Try to understand. In the direction of y, along y axis, our momentum is a constant along y axis. But along x axis, force is a zero. It means our this px momentum along x axis is a constant. It is not a zero. This is constant. Here can be any number. So if y is equal to zero, it means py is a constant. Py is a constant. If z x, y, z are coordinates. So if z is equal to 0, it means dpz upon dt is equal to 0. From here we are understanding pz is coming as a constant. Clear? What are understanding? Fx is 0. Fx is equal to 0. It means it is telling us that along x axis, along I cap, our force is 0. Force is 0. It doesn't mean that momentum will be 0. Okay, so momentum along x is a constant. Object constant. Clear? Along y axis force is 0, but momentum is a constant along y. If z along z axis force is 0, but momentum along z is a constant. Momentum along z is a constant. Okay, this was the main point. Now let's move towards the topic which is impulse. Impulse, meaning of impulse is nothing but more amount than momentum, is more amount of magnitude and direction than momentum is our impulse. Okay, so let's see what is the impulse. It's a impulse. Let me erase. Let me erase. Impulse is nothing. Impulse, this force, this is also force. Impulse force, this force will act for every for very very large for very very large force applied if magnitude is more than momentum, we will define that mb as an impulse. Okay, applied on a body on a body applied on a body for a short time for a short time interval, and in this interval and in this interval it will change it will change its value known as impulsive force. Impulsive force. Try to understand. Impulse. This force will act for any force which will act for very very large. There is a force. Okay, there is a force. For example, 400 Newton. This much force. When this much force will be applied on an object, on a body, and that object will come into motion with some velocity. Over here, we can observe that that object will come very fast. That object will come faster. At when collision will happen, then you will see that object is coming again in the same direction. Return. This force will act for a very very large force applied on a body for a short time. This is for short time interval, and in this interval it will change its value known as an impulsive force. Remember, this is a force, it is nothing but too much force is our impulsive force. Okay, for short time when too much force on a body for a short time will be applied will be our impulsive force. So long and short, too much force that can be counted. Too much force for short time will be our impulsive force. That's it. Clear? Impulsive is nothing but it is our force. Net force on any object is directly proportional. Next point is net force on any system is directly proportional to rate of change of momentum. Hence, F net external force is directly proportional. F net is on a body on any system is directly proportional. It's directly proportional to the rate of change of momentum. For momentum, we have a P. This is net force is directly proportional to P. So P is with respect to time. dP upon dt. Directly proportional to rate of change of momentum. dP upon dt. When we will remove directly proportional, then equal sign will come with the k constant. Okay. We are removing this proportional sign. F net will become equal to k dP upon dt. K is a constant. We can remove this k. by putting its value as 1. So finally our f net will become, this f net will become dp upon dt, dp upon dt. We are already familiar to this equation. From this equation you understood what dp can be written as a f into dt. You have seen. So dp, where p is a vector, can be written as f into dt. F is a vector, yeah. And here we do integrate it, yeah. We do integrate it. And over here we differentiate it, yeah. But in this case we integrate it so that we can find total change in momentum. This is used for instantaneous force. So unit of impulse, unit of impulse, unit of impulse. Impulse is nothing but ms, ns. S is a for time, n is a this for dp, for force. Okay, f is equal to dp. So ns, it can be written as kg and meter per second, meter per second. Dimension will be m l t raised to power minus 1. S is in denominator, that's why minus 1 came over here. Dimension will become m l t raised to power minus 1. Clear? This is our unit of impulsive force, which is a kg m per second, Newton second. Now let's visualize something. Now let's visualize. First, a object is thrown having some velocity. Here is a wall. This is wall. This is wall. Object is going like this. This is going object. With it has a mass. Velocity is something. Velocity is something. It is not equal to 0. Over here, this is not equal to 0. When this ball will be thrown on this ball, what will happen? What is happening? This ball after doing collision on this ball, it is coming like this. It is coming like this. V. It will happen when object has a elastic. When object is elastic, okay, this type of a collision is known as elastic collision, where object will come in some direction. Object will come in some direction with some velocity. This type of a collision will be known as elastic collision. This happened. Object came again in some direction because of object was collision. Object was elastic. Okay, object was elastic. So you would say total change in momentum is how much? Of course, in this direction, velocity will be less than inertial. So delta p will be equal to m v minus again v. Try to understand. This is the mass of the body. V is this V. So inertial, final minus inertial. So V minus, and this again minus for this, minus V will become minus plus m to b m to b means m into 2b. Here we can see mass is 1, but there are two velocities. How much? Two velocities. So finally we got delta P is equal to 2 mb. 2 mb. Two masses, two velocities. Two masses, two velocities. Clear? 2m, 2b. Now next question. Over here, again I want to repeat it. Again, let's repeat it. It is saying there is object was thrown on this ball. Then it had I think some potential energy. It had some potential energy. Then when it was thrown, this potential energy was converted into kinetic energy by the mass of the body. After collision on this ball, again it came into motion with having some velocity, and mass of the object was the same. So it came in the same direction. Velocity was not equal to 0. Okay, velocity was not equal to 0. For this case, we brought this equation. Here we are finding what is the total change in momentum after collision. After collision, what is the change in momentum? So we will get, first of all, we have only one mass, only one body. So m, and this first v, then minus, and here direction is opposite, minus b. Okay, equal to m. This will become 2b. So finally we got this equation, which is delta p equal to 2mb. We will use this formula. If you know what is the mass, let's say mass is a 10. Okay, mass is a 10. So multiple and velocity is a 5. Then you will get the 10 100 meter per second. This will be your changes in changes during the momentum. This much. This was a total change. 100 meter per second. 100 meter per second. Now let's take next question. Next point, not question. Not the question, but point. Second is absorbing surface. There is a ball whose velocity is 0. This is velocity of this ball. Now there is an object like this, and velocity is something which is not equal to 0, m. Over here, phenomena is like this. Stick after this ball, stick after collision. Stick after collision. After collision, it means after collision this ball will not come in the same direction, in opposite direction. Here ball will be over here. For this figure, for this case, what should be equation? You would say delta P delta p will be equal to first m, this m, and this our b, this our b. When we will use this equation, we will get the total change in momentum, total change in momentum. Clear? In the previous we had two velocity, but in this case we have only one velocity and one mass. Okay, over here ball is not coming in opposite direction, ball is over here with the ball. Clear? This phenomena is known as absorbing surface, absorbing surface. And previous was elastic collision, elastic collision. Elastic collision. Now third, we have a gun. Third is a gun like this. Let's see. This is a gun. Okay, bullet will come out over here. This is our bullet. This is our bullet. Initial velocity is 0, we know, and this is a complete mass. This is complete mass, which is not equal to 0. It is a mass. This is a mass. Okay. Initial velocity of a bullet is 0. Initial velocity of a bullet is 0. It means it has some potential energy over here. It has some potential energy. Now our focus is on total change in momentum. Total change in momentum. We know over here. This is also mass, but we are talking about this mass. Okay. Over here, n multiple v will give us a total change. Okay, we will get a total change in momentum from this mv during firing of a bullet. Here, what was initial momentum, not initial velocity? Whatever was the initial moment will be equal to final momentum. Okay. Momentum will be same till the final. So can you say when we will bring this pi over here, then this will become 0 equal to p a from minus pi. Final momentum minus initial momentum is equal to 0. It is equal to 0. It is equal to 0. Or you can write it as a mb. This mb over here plus mb. V is a common in this equation, minus b minus mb upon m. Minus is for direction over here. Minus is sign show that gun move opposite direction to bullet. initial momentum of this bullet was over here, but final this will be equal to 0. 0 is equal to mb plus mb again, final plus initial. V is equal to minus ab mb upon m. Sign is for opposite direction. Sign over is for opposite direction. Now next question. Particle of mass 2 kg is moving according to displacement. According to displacement time function. Time function x is given, which is equal to t raised to power 3 upon 6. Find the out of force. Found out of force at time t is equal to 2 seconds. T is equal to 2 seconds. This is our question. Particle of mass is 2 kg, which is moving according to displacement time function. Time function is given, which is x is equal to t raised to power 3 upon 6. We have to find force at given time at 2 seconds. X, which is a function, is given. Then dx upon dt is considered as a velocity. X is a t raised to power x is a t raised to power 3 upon 6. dv upon dt is equal to a is equal to t. Look at over here. This thing is given, which is x raised to power 3 t3 upon 6. There is a relation of xt. It is a relation of velocity. dx upon dt is equal to v. Okay, dx upon dt is equal to v. Over here, it can be written as t raised to power 2 upon 2. Clear? So F is equal to ma. This is formula. And over here, mass is to acceleration. Acceleration is how much? Acceleration is a t. Acceleration is a t. Here we are saying that dv upon dt is equal to a, and a is a t. Okay, a is a t. Over here, t is not function. T is the acceleration. 2t. Okay, 2t. So at 2 seconds, at 2 seconds, what is the force? What is the force? So 2 multiplied 2 will be 4 Newton. This is our force on this location, t raised to power 3 upon 6. Okay, where t is the acceleration in this over here, a is equal to t. M is 2 2 kg by the equation ax upon dt is equal to b upon. This is our first question. First question. Next. Particle having mass 2 kg is moved in from rest the variation of force with the time is shown find out velocity at t is equal to 6 seconds. Figure is like this. We have figure ft at 2 6. This area, this A1 and A2, we will uh, get a total change in momentum. A1 plus A2. Total change in momentum is known as area of a curve. Area of a curve. Area of a curve. Formula is very simple. Particle having mass of 2 kg. Let's say this is particle 2 kg is moved from the rest. From here, the variation of a force. Here force is from here to till here. Force is not constant. From 2 to 6 is a constant. Okay. Variation of a force with the time is shown in the following diagram. Find out velocity and what is a v? What is a v at t is equal to 6 seconds in this figure? This is what the question is asking. First of all, we should have a value of v. This will come this is not a xt graph here. Xt graph. A1, A2. First is a triangle and second is a rectangle. From 0 to 6 seconds. Can you write delta P will be equal to area of a curve? We are talking about this area. A plus A2. Okay, area. So M from V6 minus V0. From V6 minus V0 will be equal to 1 upon 2 and this 2 base and the altitude will be 8, then plus this rectangle 4 multiple 8 plus 6 8 plus 32 will be 40. 40 is the total change in momentum. This is a delta p value. 40 is the value of a delta p, which is equal to 40. So at 2 second, 2 v second will be equal to 40. 40. But we want only at 6 second. At 6 second. This was from 0 to 6 second. 6 second. But question is asking only at 6 second. So at 6 second our velocity will be 0. Velocity will be 0.